The peppered moth, Biston bitularia, found in England, has two color variations. The original phenotype was a pale or spotted form known as typica, and a darker or melanic form is called carbonaria. Now, try to examine this, like a guessing game. Can you find the lighter moths? How about the melanic ones? There's one here. Do you see it? Typical moths had an advantage in the lighter trees, while the carbonaria had an edge in the darker ones. Their varying colors helped them to blend into the environment and hide from hungry predators like birds. Natural selection over many generations can cause noticeable evolutionary changes in a species, and the peppered moth is claimed as its classic example. The thing about melanism in peppered moths is that because it is a classic, it has been subject to great scrutiny. It wasn't enough to simply assume that camouflage was the main reason for the success of melanic carbonaria. As always, we should not automatically assume that correlation implies a causation. It is important to investigate further how and why these moths are becoming melanic, how mutants are advantageous under the prevailing environmental conditions. Therefore, there is a need for an overlapping understanding of its ecology, molecular and developmental genetic basis, and population genetics. This is crucial for a thorough understanding of the fitnesses and selective responses of melanic alleles in nature to reconstruct microevolutionary history, to elucidate the possible mechanistic diversity, and most importantly, to validate it as an evidence for natural selection.
Tooth hypothesized that the increase in carbonaria was the result of differential bird predation in polluted regions. Kettlewell obtained evidence in support of this hypothesis in the 1950s with his predation experiments in polluted and unpolluted woodlands. Kettlewell's experiments employed the scoring experiment, which involved placing moths representing the three forms Typica, Insularia, and Carbonaria on representative pieces of bark, and differential bird predation, in which he built a large cage within an aviary, divided into two by a large sheet where one has two nesting great tits, the Parus major, and the other with numerous pieces of pale lichen-covered pieces of bark. 16 moths representing the three forms were released. Kettlewell removed the sheet, exposing the moths to predation by the birds, and monitored the experiment from a distance using binoculars and also by periodically checking to see which moths remained.
The predation experiment initiated by the release of live moths of each form onto tree trunks in the early morning and checked late in the day which moths were still present at the release points. Carbonaria was at a selective advantage over Typica in polluted wood. Importantly, the mark release recapture experiment involved the release of 137 marked Typica and 447 marked Carbonaria, accompanied by pheromone assembly and mercury vapor light moth. In 1955, Kettlewell replicated this experiment, including an unpolluted woodland in Dorset, in addition to a proper bird hide, to document some of the released moths. In one part of the predation experiment in Birmingham, 3 moths of each form were released onto a trunk in a clear view of the hide. Once all 3 of one form had been taken, a new set of 6 was released. This was done and filmed during 2 mornings and an afternoon in a 3-day period, with 58 moths being eaten by a pair of red sharks, about 3/4 or 43 of those eaten being Typica. Overall, the main principle of the evolution of the peppered moth by natural selection revolved around the environmental factor and the agent of selection in relation to the moth exhibiting Mendelian laws of inheritance.
Other researches support the evolution of peppered moth by natural selection, such as the study focused on the Insularia complex and intermediate forms of the moths, its ecological behavior, and replications of Kettlewell's experiment were also done. But despite all of this, verdicts of anti-Darwinian origin emerged that report contrasting information about the species' evolution. Reviews were written and published specifically aimed at Kettlewell, thereby ignoring other fundamental supporting independent studies and other species of moth exhibiting industrial melanism. There was also an attempt to discard Biston as an example of Darwinian evolution, and accusations of data fudging and fraud were aimed at Kettlewell as well. Moreover, criticisms became more evident as studies have been constantly carried out supporting Darwinian evolution. Critics emerged due to difficulties in knowledge and understanding of moth behavior and its ecology. Also, some of Catterwell's protocols and methodologies were questioned by these critics. Another issue to scientific criticism, where these critics were of little to no knowledge and experience in the field of biology, producing empty, unproven, and unsustainable critics. And lastly, data manipulation and or scientific fraud.
So we move on to the findings of a classic experiment of Kettleville. In his first experiment, he found that Typica was inconspicuous when rested on lichen-covered bark, but conspicuous when rested on soot-darkened bark. The reverse was true for Carbonaria or the melanic form. Then, in scoring for conspicuousness, he found that birds were responsible for the elimination of moths, which varied according to their camouflage efficiency. In Birmingham, he found that in predation experiments, a significantly greater proportion of Carbonaria were recovered, which was 62.57% compared to Typica, which was 45.79%. Catterwell argued that Carbonaria was at a selective advantage over Typica. In his Mark 3D recapture experiment, the recapture rate for Carbonaria 27.5%, double that of Typica, which was 13.1%, supporting the view that Carbonaria had a greater fitness than Typica. In his repeated experiment in Dorset, which was unpolluted, he found that of 190 moths seen eaten by birds, 86% were Carbonaria. In the reciprocal Mark release recapture experiment in 1955, recapture rates were 12.5% for Typica and 6.3% for Carbonaria in Dorset, against 25% for Typica and 52.3% in Carbonaria in Birmingham. The reciprocal nature of Kettlewell's results in polluted and unpolluted woodlands provided convincing evidence in support to the prior differential bird predation hypothesis, and this explains that frequency of the two different forms of peppered moth is dependent on the environment and evolves as conditions change.
There are corresponding findings for every criticism to Catwell's experiment. In the issues of ignorance of the ecology and behavior of the moth, there is a considerable circumstantial evidence from cage experiments that peppered moths do not usually rest in exposed position. Rather, they prefer horizontal branches. Second is the largest data set of peppered moths found in the wild was accumulated during a predation experiment. Of 135 peppered moths found, 50% were on horizontal branches, as you can see in figure 4, 37% on trunks, as you can see in figure number 5, and 13% were in smaller twigs or in foliage. In the early 2000s, Michael Maheru set out to test once and for all whether bird predation was a selective agent in Catwell's experiment. The graph suggests that the frequency of Carbonaria declined from 2001 to 2007. In the predation experiment, proportionately more Carbonaria were eaten than Typica, the difference being equivalent to a selection coefficient of 0.22 against the black form. The difference between these selection coefficients is not statistically significant. Under the category of pseudoscientific criticism, the author doubts that the bat predation accounts for as much as 90% of total predation on adult males, and he is certain that it accounts for only a small proportion of the total predation of females. Finally, in data manipulation and or scientific fraud, the accusations of fraud have been found to be vacuous, unsubstantiated, and unsustainable. While scientifically they require no further consideration as they denigrate the reputations of two dead scientists, it is to be hoped that those who invented them and others who have repeated them will retract and apologize for these accusations in print.
Darwin's theory of evolution is a gradual and slow episode of change in an organism. The primary mechanism of change over time is natural selection, and in the case of industrial melanism in the peppered moth, it exhibits the process of natural selection with empirical evidence made by Kettlewell's work. Thus, the peppered moth case is accessible and involves elements that make it easier to understand the Darwinian evolution in action and illustrate how good science is done. Therefore, teaching the story of industrial melanism in the pepper moth is necessary because aside from it is a classic example of natural selection, but also a widely used example of the difference between science and non-science. We cannot deny the fact that the case of industrial melanism is an example of natural selection because it follows the idea of having a variety, inheritance of traits, and fitness differences in an organism.